Hi Glaston, it's good to be back. So today we'll be learning about soil resources in India, which is your fourth chapter. So we had completed non-conventional sources of energy, and after that I've moved quite a few chapters before, and we're starting with chapter number 4, which is soil resources. Then we'll do chapter number 5, which is forest resources, and chapter number 6, which is water resources. So we'll be doing all these three resources because we have already completed mineral resources. So you would be noticing that throughout your class 10 you would be learning about India, the resources in India, the transportation in India, the pollution in India. We are just focusing on our own country, and India has many kinds of soil and many types of soil, but we'll be focusing on four types of soil in part 1, and in part 2 of the chapter we'll be learning about the soil, how the soil can be conserved, because we are losing a lot of soil through erosion and other activities. How can it be conserved? So that will be part 2. Just the types of soil and how it is found in different parts of our country, and how it is formed and why it is formed, all of that we'll be looking in part 1. So as you already know, some parts have already been completed, mineral and energy resources, while today we'll be looking into soil resources. Part 1 is just the first paragraph: types of soil, alluvial, black, red and laterite, distribution wherever it is found, composition, what it is made up of or what kind of nutrients it has, and characteristics such as what color, what texture, what minerals, and the crops that can grow in it. When we come to soil erosion, which is your part 2, we'll be learning what are the causes, how can it be prevented, and how can we conserve soil. In this part of the syllabus, we have already completed most of these portions except agriculture. So starting off with soil, it's a mixture of weathered rock and biodegradable matter. So you have to keep these two terms fixed in your mind. One hand you have weathered rock, which is a huge piece of rock, a huge boulder which is broken down by moisture, or it's broken down by rainfall, or broken down by wind, or a change in temperature. Last year you would have learned about weathering, and that process of weathering would have broken a rock into fine particles. But with that alone you will not get soil. You should also have biodegradable matter. It might be plant remains, animal remains, leaves, bark, or any other part of a tree, and maybe remains of an animal's or bones or something that decomposes along with it. And that together, when weathered rock and biodegradable matter mixes together in a long period of time, it takes a long period of time because there's decomposition taking place, there's mixing taking place, and then your final product is called soil. It's a long process, and this process of soil formation where everything is mixed and decomposed is called pedogenesis. Pedo means soil, genesis means formation. Good soil should have the following correct characteristics, which means how can you term that this soil is good, this soil is bad? So if you go to a place and you find that the soil has enough depth, sufficient depth for the roots to grow deep into it, that's a good quality. If it has adequate nutrients, which is a healthy development for plants, it has good in calcium, good in phosphorus, good in magnesium, good in nitrogen, then that's really good and it's going to help the plants to grow well. That's also good soil. And third one, high moisture. If it can hold water for a long period of time, that's an excellent quality for plants to grow. Ultimately, we use soil only for one purpose, majorly, which is the growth of plants and crops. So if it is helping the plants and crops to grow in a better way, that itself should be enough for it to be called good soil. So here you can see the extent to which the top layer, which is covered with grass, and below that there is the lower layers of the soil. There are different layers. The topmost layer is called humus, where it's a mixture of organic material and weathered material. The lower portions you go, you get more of soil and less of humus. So humus layer is the layer which is 99% only organic material, and there's very less portion of weathered rocks. So when you have a much more equal mixture of both, you have topsoil, then at the bottom of topsoil you have subsoil, then you have weathered rock, which is broken pieces of rock and soil together. That's why you get your underground water, and at the bottom you have bedrock. Bedrock is where all the mining or precious metals and minerals are derived taking place. This is a picture of a close microscopic image of soil. So it is a mixture of many weathered rocks, and that's unfortunately there's no biodegradable matter present in this microscopic image, but you have different kinds of rocks. All the name of the rocks found in this small sample of soil is mentioned here. Okay, what is soil made up of? You're going to learn about the types of soil, but before that, what is it made up of? It can be made up of particles, which is bigger, which is medium, or which is very fine. If it's bigger in size, it is sand size particles, medium in size, silt size particles, and fine clay size particles. So sand size particles are 0.5 mm to 2 mm, silt size particles are 0.002 mm to 0.05 mm, and clay is much more smaller than that. So you can actually see sand size particles with your own eye. You'll be finding it difficult to see silt size particles with your own eye, and you can never differentiate a clay size particle with your own eye. So does these sand, silt and clay have a role to play? Of course it does. You can look at the other pictures on the right side, where if you have a vessel or uh, any container which has sand size particles and you pour in water, it can hold more water because there is more gaps in between the particles. But if you try the same with silt size particles, it has much more lesser gap, and since the gaps are lesser, what happens is that it can hold little more lesser amount of water. But if you try the same amount of water being poured into a jar or container having clay, it will not allow the water to even seep inside. Most of the water will stay on top because the particles are so small, there's no gaps in between the particles. So the bigger the size of the particles, the more water holding capacity it has. That's a basic concept which you should remember. The bigger the size of the particles, the more water holding capacity it has. So we cannot come to the conclusion that sand has the most water holding capacity and sand is the best for agriculture. Of course, sand has the most water holding capacity, but just water holding capacity, is it enough for plants to grow? If it has more water holding capacity, which means that it has more gaps, there is also a possibility that the water can be dried up very fast. If it's too sunny, the water will easily be dried up. But on clay size particles, it will not happen, and it will be sticky and clay for a long period of time. So water holding capacity must not be the only criteria for good soil. It can be one among the many criteria. So just based on this picture, we should not conclude that sand size particles, soil which has sand size particles is the best. When you look at water holding capacity, yes, it's good. But when you look at other properties, it might not be as good. So we're going to start with the types of soil. Number one, we'll be learning about alluvial soil, which is formed by the deposition of sediments by a river. Number two, we'll be learning about black soil, which is formed by the weathering of volcanic rocks. Then we'll be learning about red soil, which is formed by the weathering of crystalline rocks. And at last, we'll be learning about laterite soil, which is formed after the leaching of minerals in rainy regions. So these are the four major types of soil. There are many other types of soil in India, but still the four most dominant kinds of soil is alluvial, black, red, and laterite. So you should also know the map of India, which has all these four kinds of soil, and which are the regions where all these four kinds of soil are really dominant and are most widely distributed. Starting off with alluvial soil. Alluvial soil is formed by the sedimental deposition of rivers. It hence is categorized as transported soil. So this is a category which we should give to every kind of soil. If it's formed by transportation, it would be transported soil. It can also be called ex situ. Situ is where it is situated. X is away from where it is situated. So it is situated away from its origin. So it is ex situ. If it is situated in the place of its origin, it is in situ. If there is a rock and it is weathered and it is formed the same place itself where soil is formed, it is not transported. It is remaining there itself. So that is the opposite, which is residual soil, in situ. Transported soil is taken away from where it is situated, so it is ex situ. So it is coarse or bigger in size in the upper course of the river, and it becomes finer and smaller in size towards the lowland or towards the plains. When we reach towards the ocean, where the river becomes wider and broader and slower. There you get smaller fine particles, but on the top of the river it is coarse particles. It is made up of fine silt, it is fertile and made up of nutrients like potassium, lime. The meaning of lime is calcium. So wherever you see the word lime, it means calcium, and also a lot of humus. Based on where it occurs, based on where it occurs. In India itself, we have alluvial soil found by rivers, but based on where it occurs, we have three types. One is deltaic alluvium or deltaic alluvial soil. It is found in the mouth of a river. Mouth is the ending part of a river. So where a river ends, you get a delta. When a river ends in the ocean, meets the ocean, which is the end of the river or the mouth of the river, you have a delta. So if you find alluvial soil in a delta, like in West Bengal, an example, you have just like how you see in the picture, deltaic alluvium. Number two, coastal alluvium, which is formed along the coast due to the influence of waves and tides. If tides and waves are causing, just like of the picture in the middle also, it's not a coastal region, but you can see ripples. It is similar to what is you see in the middle. So that will give you coastal alluvium. Third one is inland alluvium. It is far away from the ocean. Deltaic alluvium is near the ocean. Coastal alluvium is near the ocean. But inland alluvium is far from the ocean and formed on the sides of a river or on the floor of a river. Here also you can see under the river also there is alluvium. On the side of the river also there is alluvium, and it is far from the ocean. It is near the mountains. So, for example, the Brahmaputra River in Assam or the Ganga River in UP and Bihar, all these places you will find inland alluvium. The common crops that grows here are rice, wheat, sugarcane, and oilseeds. These are the important points of under alluvial soil. There are two main classifications. One is Khadar and the other one is Bhangar. So, what is the difference between Khadar and Bhangar? Here you have a picture of Khadar. Here you have a picture of Bhangar. Khadar is the new or recently formed soil, while Bhangar is the old soil. Now we look at the image in the center. You have old alluvium, you have new alluvium, and then you have the river. So as the river deposits soil again and again and again, you get new alluvium. But after 10 years or 20 years or 100 years, the river will not be as broad enough. River will become narrow and it will move far away from the portion where alluvium was deposited. Then what happens is that the region where alluvium was deposited many years ago will become old alluvium, and another set of alluvium will be formed much more closer to the river. That will be new alluvium. So above old alluvium you can see old valley floor, which means the river was flowing there many years ago. Above new alluvium you can see present valley floor, which means the river is now flowing in that region. So according to age, according to many years, the flow of the river would change, and accordingly new alluvium would become old alluvium, and now another set of alluvium also would be formed. So the new formed alluvium or alluvial soil is called khadar, which you can see light brown in color and is dry. The old alluvium which is formed is called bhangar, which is dark in color. So the khadar soil is formed at the lower levels. You can see from the center picture. It's formed at the lower levels of plains near the rivers. So the other one, Bhangar soil, is found higher levels far away from the river. Khadar soil, on the other hand, is much more lighter in color and it's formed recently. Bhangar soil is much more darker in color because it is very old. When you look at the picture of Khadar soil, you understand that it is more porous, which means it can hold a lot of water. If you pour water in Khadar soil, it can absorb a lot of water. It is porous in nature and it is loamy. Loamy means equal mixture of sand, silt, clay. That is called loamy. It is loamy and it is porous. While Bhangar soil, because it is old, it has become clay and sticky and it is non-porous. It cannot absorb a lot of soil. Because Khadar soil is porous and loamy, it is much more fertile and can support a lot of crops. So it is more fertile. While Bhangar soil, because it is old and it is clay, it doesn't absorb a lot of water. So not much crops can grow in Bhangar soil. So it is less fertile. So these are the five important points. To remember all these 5 points, you have to fix the center picture in your mind. The far away it is from the river, the closer it is from the river. That differentiate Bhangar and Khadar soil. The second type is called black soil. It is formed by the weathering of lava rocks. When lava cools down, you will get something like this. Then after that, you break it out, you will get lava rocks. And after the lava rocks break down and weathering happens, you will get black soil, which looks like this at the bottom. This black soil is also called regur soil. And since it is formed in the same place, it is not formed in another place, it's formed in the same place. So it is categorized as residual soil. Remember, alluvial soil was transported because it is formed by transportation. This is called residual or in situ soil because it is taking place without any movement. Black soil is low in humus or organic matter, but it is high in potassium, calcium, iron, and magnesium. Most parts of the Deccan Plateau in India, the southern peninsular India, is composed of black soil because the Deccan Plateau many years ago, the plateau was formed by a huge volcanic eruption. So that volcanic eruption would have left many black volcanic rocks, and when the rocks weathered, it would have formed all the black soil. So the central part of India, including Madhya Pradesh, Maharashtra, are two states where black soil is very highly dominantly found. Black soil is clay in nature and is fine grained. Cotton, wheat, and sugarcane grows very well in black soil. Especially cotton grows excellently well in black soil in the states of Gujarat and even Maharashtra. Moving into the third type, we have red soil. Red soil is crystalline rocks which, as the presence of iron, undergoes oxidation and it comes in contact with atmospheric oxygen. You would have learned the process of oxidation under chemical weathering last year. So when a rock which has iron, it is coming in contact with oxygen either through rainwater or through the air, it starts to rust. This reddish brown substance which is produced over a rock. Now you can see the picture of the rock and you can see a reddish brown tint over the rock. When these kind of rocks, which is crystalline in nature and has a lot of iron and it started to rust, when this starts to weather, it forms this kind of red soil. Hence it is also called residual soil because this also weathering is taking place and it is not moving. It is residual because there's no transportation takes place. It is coarse, crumbly and porous in nature. The soil is rich in iron but deficient in phosphorus, nitrogen and magnesium. It is not good for agriculture. You should remember that alluvial soil is good for agriculture, black soil is good for agriculture. But the third and fourth type which you're going to learn, laterite and black soil, and red soil, these two, the third type and the fourth type, red soil and laterite soil are not good for agriculture. These can still be used if fertilizers are used. Rice, wheat and sugarcane are common crops grown in red soil. Eastern regions like the Andhra Pradesh, Odisha, Telangana, Jharkhand, where there's the Chota Nagpur Plateau, all these eastern regions of India have lot of crystalline rocks, and then these crystalline rocks have iron and they go undergo weathering and they form red soil. So it's formed on the eastern side of India. Moving into the last type we'll be learning today, which is laterite soil. This soil is formed due to the process of leaching. What is leaching? When there's heavy rainfall, the soluble matter, even if you take a lump of soil in your hand and put it in a glass of water and start stirring it, the water color will change because of the soluble matter. But still, in that same glass, there will be some sand size particles, some silt size particles, some clay size particles, which are insoluble. There are some portions of the soil which are soluble, and when that is removed, that process is called leaching. But don't get confused that because of leaching it's transported soil. No, it is not transported soil because the soil is not about the matter which is leached. Laterite soil is not about the matter which is leached or removed. Laterite soil is the remaining or left out matter after leaching has taken place. So just like weathering after leaching has taken place, the soil is what is remaining. So after there is heavy rain, lot of soluble matter is taken away. What is remaining is called laterite soil. So you can see there are, after rainfall is happening, after rainfall has taken place, the soluble matter is removed and you have small granules which cannot be dissolved and it remains. This is called laterite soil. So this is also a residual soil. Among the four types, only alluvial soil is transported or ex situ. Remaining three types are residual or in situ. The formation of laterite soil is more in the areas where rainfall is high and dominant. Since more rainfall, there will be more leaching, and if there's more leaching, there is more remains of laterite soil. So red soil was formed on the eastern regions of Telangana, Andhra Pradesh, Tamil Nadu, while this soil is found in the western regions because western regions have western Ghats which experiences so much of rainfall every year. Kerala and Karnataka are two states which fall under the western Ghats. So these regions will have a lot of laterite soil. Laterite soil also is acidic in nature, crumbly, coarse. Iron and aluminium are very high while calcium and silica are less. Another very important feature is that laterite soil, if it is left out on the land, it hardens as a rock, and that can be cut out into cubes and made into the shape of bricks. And this laterite soil will act as a brick by itself, because when the soil is exposed to sunlight, the soluble material is already removed. So whatever remaining, when it is exposed to sunlight and air, it becomes so hard, it's become so hard and hardens like a rock, and it can be used as building material, like how you see in this picture. You can cut it into cubes, you can cut it into bricks, and you can use it as building material. It is also not suitable for agriculture. So red soil and laterite soil not good for agriculture, but still agriculture can happen when fertilizers are added. Coffee, rubber, tapioca and cashew nuts are the important crops grown in regions having laterite soil. So these are the four main types of soil in the soil resources chapter. This is the last slide of today, and with this we'll be ending. So here you can see all the soil types. You have two soil types which are extra in this map, which is arid. Arid is nothing but desert soil, is found in Rajasthan, some parts of Rajasthan, not all parts of Rajasthan, where you get the Thar Desert, while you have forest and mountainous soil in all along Sikkim and Jammu and Kashmir, and also Ladakh, Uttarakhand, Himachal Pradesh. But comparing the rest of India, you have the major soils which you have learnt. Alluvial soil, where do we find it? Along the Ganga plains and the Brahmaputra plains. It is marked in green color in the map. Light green color in the map is alluvial soil. Number two, black soil. Where do we find black soil? In the central part of India, where there is volcanic eruptions hardening to form the Deccan Plateau, and the Deccan Plateau weathering to form black soil with a grayish purple tint you can find in the center, which is black soil. Also in some parts of Gujarat, also you find black soil. Red soil is the third one, which is formed along the eastern margins. I told you it is formed because of the weathering of crystalline rocks, and the crystalline rock should have iron content. So oxidation process happens, rusting happens, and then it weathers. Red soil is formed all along the eastern margins of India, especially in the states of Tamil Nadu, Telangana, Andhra Pradesh, and Odisha. Last one, laterite soil dominant in rainfall regions like the Western Ghats. Along the Western Ghats, you can see pink regions here and there, but there's a huge patch of pink region, straight vertical patch along the Western Ghats. You can see that is one big example of laterite soil. So keep some areas in mind, because all the areas of all the soil to keep it in mind is difficult. But if we keep, for example, Ganga Plains, alluvial soil, Deccan Plateau, black soil, eastern margins, red soil, and Western Ghats, laterite soil. If you keep one area for each soil in mind, it is going to be really easy. So I hope you understood the first part of soil resources. We'll be learning about how it can be conserved and how soil erosion takes place and the prevention measures in part 2.